Hi everybody, this is Chris again. Just following up on my previous video which discussed QuikTrak. Some time ago I was interested in IoT devices, and as is the way the IoT devices, at least which I've encountered, published their sensor readings in a JSON format, which is pretty straightforward to understand. Some were compressed message streams, kind of, stuffing bits into bytes and trying to be very efficient because data was being transferred over satellite links and so on. But ultimately, after that kind of, binary format, if you will, had been received by some central hub, it was then, made available downstream in a JSON format. So again, I'm going to repeat this thing. I want to show, not tell. So let's use our previous context as a basis for this discussion. We have a bunch of people. They are members in some organisation and they're divided into groups and so on. And we see our schema there is the same as last time I presented this. So we've got members. They are in roles such as an admin, a member, a leader, and a status, and they're also members of a group. But what we've done since last time is pretend that these members have devices. And these devices, as an example here, are a smartwatch and an environmental monitor. Now those devices have a device type, as we've just seen, so here's the reference data for that, which could be set up as an enum table in Hasura. And what else can we say? So we've got the device type, and then the devices are ultimately seen as the source of some kind of message. So when we think about a smartwatch, it might give us something like our body temperature, the number of steps that we've taken, the blood oxygen level, the heart rate, and this person doesn't look very healthy today, right? At 25 degrees, probably feeling a bit chilly or maybe dead, I'm not sure. Anyway, this is just a bunch of messages, and I always like to keep the data set quite small so it's not overwhelming to look at or read. So in essence, we have a bunch of messages which we pretend came in from a smartwatch and a bunch of messages that pretend to come in from an environmental monitor. Now here's the challenge. As far as I know, I first did this a few years ago, but as far as I know, Hasura GraphQL doesn't have a way of surfacing the values from this JSON data, which in Postgres database terms is a JSONB column, i.e. it's just a blob of JSON. So we need to help Hasura bust these column names, if you like, and values out of this JSON data so it can be queried and tracked. So what we've done, let's skip to source code and get a little bit more technical, is when the tracker runs, remember last time we saw that it was untracking stuff that it'd done before, and then it tracked tables and then it tracked relationships. Smack bang in the middle here we've got a couple of new features this time. One is a bunch of scripts to be executed before we build these mystical JSON views, and then a bunch of scripts after those views are built are then executed. So our directory structure now looks like this. We've got a bunch of scripts which we can run. There's nothing in them at the minute, they're just an example structure. But these scripts would run before the JSON views are built, and these are the scripts would run after. So for example, if we wanted to, these before scripts might delete all the data, then inject new data, and after is really just a kind of a sequence. It helps us overcome a sequencing challenge. Like when you have two tables that relate to each other and you want to create the tables first and then follow that by creating the foreign keys between them afterwards. It's similar to that. It just kind of helps you work around if you've got any sequencing problems with some scripts have to run after the steps have completed. Anyway, enough of that. We can basically run custom scripts. So these JSON views that get built right in the middle of the process here, let's look at those. So the objective of these views is to take that JSON data that we saw from that column and make it available to us as though it was a SQL table. Well, to do that, we're going to use a Postgres view, but we don't want to be going in and rerunning scripts manually. We want to run the tracking process once and it do everything in a single click. Now, this looks quite involved, but it's actually quite intuitive when you've done it the first time. So, for example, I did my smartwatch example first, and then when I thought, I'll just pretend I've got an environmental monitor as well, doing it the second time was pretty straightforward. It's probably something that you want to do, kind of like make this run in a SQL query tool first and then drop it into the JSON file here. But let's take a close look at what's happening, and we can make this a little bit more readable simply by doing this. So imagine we have a JSON view which selects standard SQL values. So from the IoT messages table, we want the message ID and we want the time that the message was created at. We also want to be able to connect this view with this JSON projection, if you like, in it. We want to connect that view back to the source message that the JSON view came from. And then in turn, once we can connect this JSON view to the source message, we can then navigate back to the device and find out the device type and other useful stuff. So this is why we've got these inner joins in here, where I can now get the devices related to the message and the device types that published this message. So that's really what this join stuff is about. So let's just make sure that's back there nice and tidy. So we've got a select statement saying we want to select from IoT messages, and we're joining in other things to help us get the device type. So after those joins, now we can say for this smartwatch view, I only want IoT messages that came from a smartwatch device type, and I want them to be ordered by the time at which those messages were created. So imagine that SQL statement is doing just that. Get me my smartwatch messages, and then when we move down and say, in addition to the message ID and the created time, I would also like from the JSON the temp attribute, heart rate attribute, and steps attribute. But in my GraphQL world, I'd like them to be called this. So this is like in Hasura when you can give things custom names. And then I also want them to have a data type. So the temperature might come in as a string or as something, whatever. Now we can say it's a float in our GraphQL world, or an integer or text, whatever suits us. Once we've got this tracking information set up at the table level, we've got this SQL select and then the JSON attributes that we want projected out almost like a SQL format, then the next thing that we want to be able to do is create another relationship which connects this JSON data back to the original IoT messages entry. So that's what we're doing here. We're saying that this view that we've created, its name is right here, IoT smartwatch. So let's correct that actually. This IoT smartwatch has a message ID, and that's referencing the IoT messages message ID. So now this JSON view can help us navigate back to the source message from IoT messages table, and we have a similar issue here. IoT environment message ID messages back to the refers back to the IoT messages ID. So let's do our famous throw everything away. So we can start with a clean database, and then we build it back up. So remember, this whole project kind of gives you this ability to blow the whole environment away and rebuild it clean. So let's just take a quick look back at our initDB structure. Remember there we had the create schema structure. So there's our old membership stuff we saw last time. And here's our new IoT device types, then the devices, and then the messages from those devices. And then we have our previous attempts to load test data into members and groups and so on. And here we have a bunch of device types being created. We have the devices themselves, which are then assigned to a member. In this case, we know it's going to be Jack because it's member 1. And then we shove a heap of messages in there. The first set of messages are going to device 1, and the next set of messages are going to device 2. So device 1 is Jack's smartwatch, and device 2 is Jack's environment monitor. Okay, so now basically we've got our environment created. Let's get it all tracking, and remember we're still trying to fix this bug where we have to run the thing twice to fix a race condition. Anyway, here we go. Let's see what we found again. So again, QikTrak tells us, yep, I know what you want me to do. Untracks the previous table setup, executes any custom scripts, builds the JSON views, and then once those views are built, now we can see that they're being tracked. So in addition to our member data, we've got our IoT device types, devices, and messages, but now we've got these additional views that are helping us track the environment information and smartwatch data. So once again, let's go jump across and see what Hasura makes of all this. I'm ignoring this at the moment, a little bit puzzled as to why it thinks that some relationships aren't tracked, but what you'll see if you'll explore this yourself is that everything actually seems to be in place that needs to be, so I'll cycle back to this later. So let's look at our tables. We've got our members, roles, status, groups as we had before, and now the member has devices, IoT devices, which have a device type, and then they have messages. So let's jump across and make a query. So if we say, let's have a look at members. Again, we know they have a first name and a last name, and members have devices which have a description. Let's check this out first. So we can see that one of the members is called Jack, and he's got a smartwatch and an environmental monitor, and nobody else appears to have any smart devices of any kind. So far so good. So let's take a look then at the sorry, I've got to clear this out. At the IoT smartwatch data. What can we get from that? Well, we can get your saturation levels for the oxygen in your blood, what your heartbeat was, how many steps you've taken, and we'll see in a moment that you don't appear to be very well. Body temperature's 25 degrees. That's I'm not quite sure whether anybody would actually be alive there, but do you get the point now? When we look at the data and the IoT messages, we had this kind of almost inaccessible, or at least we couldn't really query against it from the GraphQL world. So all my JSON data now is presented really nicely in the same structure that any normal SQL data would be. I think I'll leave it at that. We're just coming up on 15 minutes, and I think YouTube's recommendation is to not go to 16 minutes, otherwise you'll get bored. I hope you enjoyed that. I think the best way, if you want to go deeper, is dive right into the code. Since the last presentation, I've refactored a lot of things, so everything used to be kind of in one big module. What I've done is made the QikTrak is kind of like the key guts of understanding what the SQL database has got in play, and then kicking off the tracking in the right order. But if you take a look at this QikTrak Hasura module, this is where you could learn about using the actual Hasura metadata API, and you might find that really useful. Log is super simple for writing out to the console log, and QikTrak names is used for doing those things like removing the underscore ID from member ID to give us like relationship names and so on. Okay, there you go. Please do jump on the Hasura Discord community there and give me some thoughts, any questions and feedback. And if you get a chance, jump onto the Git repository, input any issues there, and if you can help me fix what I think is the only issue, which is the race condition, then I would be really grateful for your help and support. Thanks everybody.